Let's now talk about the chemistry of phenol. Let's talk about how we produce it and how phenol reacts. One way of producing phenol is by taking aniline or aniline salt and adding it to nitrous acid above 10 degrees Celsius. Nitrous acid is produced by this reaction, by reacting sodium nitrite with hydrochloric acid. Then we'll be able to get phenol and nitrogen evolving, and hydrogen gas and water is also produced. And we can also obtain phenol and by basically heating diazonium salts in water, and we also get nitrogen evolved, and HCl will also be produced. The OH of the water goes here, the H goes away with the Cl to form HCl. And as we can and I should also probably note that like amines and amine salts, like if they were reacted with nitrous acid below 10 Celsius, it will form the diazonium salt. Yeah, so if we do this below 10 Celsius, this will produce this, and we have to heat this to produce phenol. So without doing that process, we just do this about 10 Celsius and this reaction will produce phenol. Aniline is interesting for it is more acidic than water but less acidic than carbonic acid. However, it is acidic enough to turn blue litmus into red litmus, but because it's less acidic than H2CO3, it cannot liberate carbon dioxide from carbonates or bicarbonates. Now, as for reactions of phenol, phenol can react with sodium to form the respective alkoxide, which is phenoxide in this case, and evolve hydrogen gas, which under which which under and if we were to do so with sodium hydroxide, we will also get the same phenoxide ion, sodium phenoxide, but hydrogen gas will not evolve. If phenol doesn't react with carbonates and bicarbonates, and if we were to add water, acidic water, ideally into the sodium phenoxide, it will produce phenol again. Phenol and reacts with water to produce carbolic acid, which is a powerful antiseptic. And phenol can react with zinc dust to produce benzene. Phenol reacts with acid halides to produce esters, because phenol is like an alcohol, and acid halide alcohol ester. Yeah, so this is a esterification reaction in which we have this benzoyl ester with NHX is also formed. We also have a hydrogen halide being formed. We can react phenol with chlorine aqueous or bromine aqueous to get these salts, where the chlorine and where the halide atoms they go to the ortho positions and the para positions to produce this white precipitates. This one is a light yellow in particular. Yeah, this is 1,2,3 tribromophenol. This is 1,2,3 uh, trichlorophenol. If we were to react phenol with diazonium salt, we will get a red-orange color azo dye, which looks as follows. You see, the H and Cl react, and this triple bond turns into a double bond, and this bond goes to attach to this. You see, phenols, if we were to add concentrated sulfuric and nitric acid into it, it will just oxidize rapidly and virtually form ash. If we were to use concentrated nitric acid only, we will get 1,2,3 trinitrophenol, which is also which is an explosive, by the way, picric acid. And yeah, there's this thing called if we were to take like toluene CH3, which is basically CH3 attached to the benzene instead of OH, then we will if we make it undergo this reaction, we will be able to get trinitrotoluene or TNT. If we were to react dilute nitric acid with phenol, we will be able to get nitrophenols at various proportions. Mostly of the where the phenol is at the ortho and para positions, where the ortho position is more ortho substituted species orthonitrophenol is produced more than paranitrophenol at and we have a very big minority of very small minority of metanitrophenol, and these are the chemistry of phenol.